Chapter 2 will start at kind of a basic level, talking about markets and how they operate. What we're going to see is that, again, 2 will look at things in a really sort of general fashion, and when we get into some of the later chapters, we'll do a little bit of time talking about demanders or customers by themselves, and we'll spend a lot more time talking about suppliers and industry concentration and things like that. But here in Chapter 2, we sort of put them both together and see how individual markets behave in terms of the prices of the product that is sold in that market and the amounts of that product that are sold also. Well, the best thing to do to analyze markets is you have to look at both sides individually, figure out how the demanders behave, how the suppliers behave. So on the demand side, we want to identify who these demanders are. And we're talking about a particular product, and the demanders of that product are identified as people who are both willing and able to purchase that product at a set of different prices. So if you remember back from your undergraduate economics classes, you have these demand curves, downward sloping demand curves, and they show the amount that customers are willing to buy at all these different prices. And again, a key here is going to be the fact that these customers, the demanders, are only the people who are both willing and able to buy that product. They may not be, you may find a lot of people who are able to buy the product, they may have enough money to buy it, but they're just not willing to. They don't want the product at all. You would not consider those people to be demanders. Or you could find the reverse, people who really desired your product, but if it's very expensive, if they're not able to purchase it, then you wouldn't consider them to be demanders either. So when we think about the factors that affect consumers and their demand decisions, there are, well, the book lists 6 of them, and we might be able to come up with some others as well that might not fit neatly into these categories. So they're just sort of the ones that sort of jump out at us the most. The factor that's the most important will be the price of the product itself. So when I'm deciding how much of a product I want to buy, the first thing that I really care about is the price of that product. But there are other factors too. The amount of income that I have, the prices of related goods, and these fall into the categories of substitutes and complements. 2 products are substitutes if they perform similar functions. So Coke and Pepsi, different brands of tortilla chips or something like that. So if the price of Coke changes, that's going to affect the demand for Pepsi. And we'll discuss a little bit later the direction of that effect. If 2 products are complements, you may hear people talk about, oh, those 2 people who are dating, they complement each other well. That's sort of what we mean when we're talking about products that complement each other. It means that people tend to buy those 2 products together. So peanut butter and jelly, or tortilla chips and salsa, hot dogs and hot dog buns, those sorts of things. So if the price of peanut butter goes up, we would expect that people say, well, I don't really just want peanut butter itself, I want to make a sandwich, so I buy peanut butter and jelly together. So if the price of peanut butter were to change, then that would affect the demand for jelly. And again, we'll talk about the direction of that effect later. The taste patterns that consumers have, they may have a change in their preferences or their tastes for a particular product. 10, 15 years ago, people loved pastas and breads, and now this carbohydrate thing, people don't like them anymore, much to my dismay. And so people's tastes have changed. Still hasn't really affected my consumption of pizza, but it's kind of hard to quantify that somewhat. You might be able to just have a value that increases if consumers desire it more or decreases if they desire it less. Future prices. If people expect a price to rise in the future, they may decide that today is the day to buy it. So if we're looking at the demand today for a particular product, if the price expected in the future were to go up, then people would tend to purchase more of that product today, as long as it was a product that could last more than a particular number of days. If it was a gallon of milk or something that wouldn't last very long. If you expected the milk price to be higher a year from now, well, that wouldn't really affect your demand for milk today, because you can't put milk in a refrigerator for a year and have it last that long. The last one is kind of recognizes the fact that demand, how we're going to define demand, is the demand of everybody, all of the demanders for the particular product. So when we look at a demand curve, it reflects all of the people who are willing and able to buy that product. And so this might be for a particular city or a state or even a country. So if we think about the demand for Coke in Shreveport, well, there's at a particular price, there are so many, probably millions of cans, I don't know, that are bought and sold in Shreveport in a given year. Well, if the population of Shreveport doubles, so there's a bunch more people who live here, there's going to be a lot more consumers here. So even if the price stayed the same, if the number of consumers goes up, then the demand for Coke in Shreveport would increase too. So we can kind of algebraically show all of that in this general demand function down at the bottom. And we could write it out algebraically also, which will be good because when we get into some of the later chapters where we do regression analysis, we'll set it up like this. So we have an algebraic equation written out where the quantity demanded depends on an intercept term A, and then we have all of the other variables that we felt were important: the price, income, prices of related goods, those sorts of things. Well, the lowercase letters in front of those, the B and the C, the D, those are all what we call slope parameters, and they will reflect the influence that those individual variables, the P and the M, have on the quantity demanded. So we're able to sort of quantify the effect of a change in the price and how that impacts the quantity demanded. A way to think about these different slope parameters, parameter B there, represents if price were to change a certain amount, then we would expect that the change in quantity would be reflected in the value that B has. And if you remember calculus, you remember your calculus, those of you who've had it, then a way to interpret these things is that when I look at the value of B, what that tells me is this is the effect of price on quantity, holding all of the other variables constant. So it would get confusing if the interpretation of B was not dependent on the fact that these other variables were held constant. Because if I looked at the value of B and it was a certain number, but I didn't know, well, the price seemed to go up 1%, but at the same time the income of consumers went up 3%. Well, it would be difficult to interpret the effect that would be had on the quantity demanded. So when I look at the coefficient of B, when I look at the value of B or the value of C, my interpretation or my assumption is that all of the other variables are being held constant, and so it's just sort of the single direct effect of price on quantity. Again, the sign of that variable, B or C, tells me how it's related. So I would expect that, well, if there's a positive sign, obviously, then if the variable increases, then the quantity demanded increases. If the coefficient has a negative sign, then as that variable increases, the quantity decreases. So we can think about some of these variables and see how they're related to demand. For most products, as the price goes up, people buy less of it. As the price decreases, people buy more of it. So there's an inverse relationship between price and the quantity demanded, meaning that as the variable moves in one direction, the quantity demanded moves in the opposite direction. So that implies that the value of B is going to be negative. For income, you have to be a little careful. We probably mostly assume that as income goes up, then people are going to buy more of a particular product. And that's probably true for most things. We call those normal goods. If income goes up, people tend to buy more of something. That's probably true for steak and cars and square footage of a house, that sort of thing. But it's not true for every product, because you could conceive of things like ramen noodles, the cereal that they put in bags instead of the cereal they put in boxes. Those sorts of things, when people's incomes go up, they probably buy less of those things. We tend to refer to those as inferior goods. That doesn't necessarily mean that the products are of lower quality, although they sometimes might be. But when an economist talks about an inferior good, we're really only describing this relationship between quantity demanded and income. There may be things that are quite expensive that are still inferior goods. You might think of a compact car, maybe. I mean, you got to shell out a couple tens of thousands of dollars for a compact car, but we would still presume that that's probably an inferior good. As the income goes up, people probably buy fewer compact cars. Again, we're not saying anything about the quality per se. The quality of the compact car might be very good, it might be have very good crash ratings and things like that. But most consumers tend to behave in a way such that as if their income goes up, they buy fewer compact cars. So that would imply that for inferior goods, the coefficient of C is negative. And I forgot to mention, for normal goods, the coefficient of C is expected to be positive. So one nice thing about looking at these signs of these slope parameters is that sometimes it might not be very clear how consumers perceive your product to be. You might have something that's kind of on the edge. Well, I'm not sure if it's a normal good or if it's an inferior good. Well, if you can do some statistical analysis and observe what the sign of the C variable is, then that gives you a better idea. We talked about these related goods, substitutes and complements. Our substitute example was Coke and Pepsi. And so if the price of Coke were to rise, then we ask ourselves what happens to the quantity demanded of Pepsi, even if the price of Pepsi stays the same. And I should have mentioned that with the income variable too. When we look at the value of C, again, we're presuming that, well, if income changes and the price of the product stays the same, what happens to the demand for that product. So if we go to the Coke and Pepsi example, if the price of Coke goes up and the price of Pepsi stays the same, then what happens to the demand for Pepsi? And even though the price of Pepsi stays the same, since we know that Coke and Pepsi are substitutes, if Coke is more expensive, people are going to stop buying Coke as much because they say, well, Pepsi is a good substitute, I'll just drink that instead. So if the price of Coke goes up, the quantity demanded of Pepsi increases, and we would expect that the coefficient would be positive in that case. Again, if the price of Coke goes up, then the quantity demanded of Coke goes down. But since we're talking about the quantity demanded of Pepsi, if the price of Coke goes up, quantity demanded of Pepsi would increase also. When we looked at our peanut butter and jelly example, those were complements, then we would think, well, if the price of peanut butter goes up, then people say, well, it's more expensive to make my sandwich now because the peanut butter part of it is more expensive. And even if the jelly price stays the same, people, again, they say, well, the sandwich is more expensive. If peanut butter is more expensive, I don't want to buy as much of it. And there's not really much sense in having a small amount of peanut butter and a bunch of jelly sitting around, so I'm not going to buy as much jelly either. So if the price of peanut butter goes up, then the quantity demanded of jelly goes down, and that would make the coefficient there negative. Inversely related for complements. Knowing these things is really useful, again, for businesses, because sometimes, again, we don't know exactly how our consumers consider the relationships between two products. We might sell a particular type of product, and we might have an idea of who our competitors are because we have a little more inside information about how the industry works. But what really matters is how the consumers feel about who our competitors are. And I guess just talking about Coke and Pepsi again, you might know some people who drink Coke and they'll drink Pepsi just as easily. They don't really care. But you might also have some friends who say, well, I love Coke and I just can't stand Pepsi. And to an outside observer, they might just say, well, Coke and Pepsi, they look similar, they taste similar, yeah, of course they're substitutes. But again, if there's a significant number of people in the second category who say, I love Coke, I hate Pepsi, well, they wouldn't consider those to be substitutes at all. And you might get a value of D that is close to 0, maybe positive somewhat. But if there's a big group of people like that, then you might get a value of D that's close to 0, meaning there really isn't any relationship between those two. So it's good, again, for businesses to figure out who their competitors are in terms of how the customers perceive it. And again, on the complement side of things, you might sell peanut butter and things are going well in your company and you don't have really anything to worry about, business looks good, but you see something happening in the jelly market. Maybe there's a crop failure and it's harder for the jelly companies to make jelly. Nothing's happening in the peanut butter industry, you're still doing fine. But if you notice, again, that there's something happening in the jelly industry, you might be able to predict the impact on your sales if you knew how strong the complementarity is. If you knew the value of D, you knew it was negative. But it could give you a sense of, well, we predict that because of this situation in the jelly market, it's going to affect jelly sales, and that's probably going to affect our peanut butter sales too. If you knew the value of D, you'd be able to make a good prediction about that. Taste and preferences, again, it's kind of hard to quantify these somewhat. Again, if you collect the data such that if consumers value it more, if their preferences increase for that product, then there would be a direct relationship. The value of E would be positive there. Expectations for the future, again, since we're looking at the quantity demanded today, if consumers think that prices are going to increase tomorrow, then they would probably buy more today because they want to buy when the price is relatively lower. So if their expectations increase, then their demand would also increase. So there would be a direct relationship. Again, you might think, well, but they're thinking that the price is going to go up, so wouldn't they buy less? Well, yes, they are planning to buy less tomorrow, but in today's terms, when the price is relatively low, then they're going to buy more today. And again, as the number of consumers increases, then the effect on demand would increase too. We can trim up that equation a little bit and talk about, well, what is basically the relationship between the demand for the product and the price if we hold all the other factors constant? Well, for most products, again, there's this functional relationship between the price of the product and the quantity demanded. And for just about everything, the relationship between these two variables is strong enough and recurs enough that we invented a law for it. We say the law of demand, where there's this inverse relationship between the price of the product and the amount that people buy. So when the price falls, people buy more, everything else constant. When the price rises, people buy less, everything else constant. And again, that everything else constant is going to be really important, because if you had the price of something falling, but you also had people's incomes falling, let's say for a normal good, well, the price falling would tend to push the quantity demanded up, but the income falling would tend to push the quantity demanded down if this is a normal good. So having those two things change at the same time, you might get questionable results in QD. You might have sort of surprising or unexpected changes in quantity demanded. So when we talk about the law of demand, it's important to have this caveat that we're trying to hold everything else constant. And if that's true, if you can hold everything else constant, then this inverse relationship tends to reveal itself. And so the B coefficient that we had is usually going to be negative. Even though we tend to think about consumers responding in their demand decisions to changes in the price, where that would imply that, well, the price is the independent variable and the quantity demanded is the dependent variable. For historical reasons, we tend to draw the price on the vertical axis as the dependent variable and the quantity demanded on the horizontal axis, or the independent variable. You can blame Alfred Marshall for that if any of you know who he is. He's not alive, so you can't blame him for this. But he's the one that kind of started it. So because of that, and that tradition of having price on the vertical and quantity on the horizontal, then we have to sort of flip our demand equation around so that we can have price as the left-hand side variable and the quantity on the right-hand side. And so we call this an inverse demand function. It doesn't mean that when we say inverse demand function, we're not talking about the fact that the quantity and the price are inversely related. We're just saying that, well, we knew the original demand function had Q on the left-hand side and P on the right-hand side. When we have this inverse demand function, then we're switching it. We're putting P on the left-hand side and Q on the right-hand side. The reason we talk about this is so that we can put things in a graph form. Graphs are just simple pictures that describe what's going on, that really encapsulate a lot of information into one chart. And so on this demand curve, you can think of it two ways. We're sort of reflecting the extreme situations for the consumer. So any point on a demand curve is going to show, I guess you can think of it two ways, the biggest amount of a product that people are going to be willing to buy at a particular price. Or you can flip it around and think of people wanting to buy a certain amount and then say, well, what's the highest price they're willing to pay for it? So in both cases, it's sort of an extreme for the buyers. And I believe the book has this chart as well, but they didn't give you the equations for it, if I remember right. So I sort of graphed it out and figured out what the equations would be. You may have data when the product price was $120 and you sold 200 units, when the product price was $100 and consumers wanted 400 of them, and you can construct this demand curve out of it. And you see it's downward sloping again, shows you this inverse negative relationship between price and quantity. And the actual equation of this line is given as that inverse demand function. So you see again that price is on the vertical, quantity is on the horizontal. So if you're actually going to determine the equation of this line as it's written, as it's drawn, then you would get the inverse demand function that's written there. P equals 140 minus 0.1 Q. So again, between points A and B, you can see this inverse relationship. As the price falls, the quantity demanded increases, everything else equal. And it's kind of interesting to look at a single demand curve where it is, because you get a sense of how responsive consumers are to changes in the price. But things change over time. I mean, looking at a single demand curve does give you a little bit of flexibility, because you can observe what happens when the price of the product changes. Well, if the price of the product changes, I move from one dot on that demand curve to another dot on the demand curve. So it's flexible in the sense that the demand curve itself can show you what happens when there's changes in the price. And that's kind of helpful. But in life, there are these other changes that happen too. There might be a change in people's incomes. There might be a change in the price of jelly, causing the demand for peanut butter to change. So there are these other factors that can change too. And we refer to those as a change in demand, contrasted with a change in the quantity demanded, where you're staying on the same demand curve. But a change in demand means that even if the price of peanut butter stayed the same, if the price of jelly changes, then the demand for peanut butter is going to change. There's going to be a different dot other than the one that was originally drawn. And that means that all the other dots are going to move. So there's an entire shift of the curve when something besides the price changes. So either, again, income, prices of related good, expectations of future prices, if any of those things change, even if the original price of the product stays the same, it's going to move those dots on the demand curve around and make the entire demand line shift. An easy way to think about this, I tell my principal students this, if one of these changes happens and you expect there to be more demand, then it's going to make the demand curve shift to the right. And you can kind of remember that because there's R's in both. More has an R, right has an R. If something happens where you think that demand should be less for the product, then you would shift it to the left. So here we have one of our demand curves, we'll call it D0. You see it slopes down. And when we think about whether these demand curves shift, again, the question is, if the price stays the same, but there's this other factor that's changing, then what's going to happen is that each of the individual dots that make up the demand curve is going to move. It's going to shift to the right or to the left. If the price stays the same, but people want to buy the product more than they used to, then the price stays the same, but the quantity demanded dot increases or shifts to the right. That means the entire demand curve shifts to the right. So if we had our D0 demand curve here, and let's say consumer income goes up and D0 is a normal good, then that would cause each individual dot to, at the same price, it would be associated with a higher quantity. So the demand curve would shift to the right like D1. Or you might have a product where D0 has a substitute, and if the price of the substitute product decreases, so the substitute is cheaper, then people are going to buy less of this particular product. So even if the price of this own product stayed the same, if the price of the substitute is cheaper, then at the same price people are going to buy less of this product, which would cause the demand curve D2 to be shifted to the left. Alright, so we're ready for supply. And it's going to be similar slides, similar discussion. The amount supplied is going to reflect the amount of a particular product that businesses or whomever is willing to supply at different prices. And we should have also indicated the fact that these have to be people who are willing and able to sell the product at different prices. And again, both of those willing and able is going to be important too. Just like with demand, there are other factors that cause supply to change. The most important ones, of course, going to be the price. But there are other factors too, other input prices. So, every company needs inputs or needs ingredients, if you want to think of it, to produce the product. We call those inputs. So for teaching at LSUS, the LSUS requires professors as an input, requires electricity as an input, requires heating and air conditioning as an input. So if the prices of any of those things change, it affects the amount of teaching services that LSUS is able to supply or willing to supply. We can also think about related goods in production, substitute goods. So a company might be able to produce other products besides the one that it's currently producing, and they might consider that a substitute product. Technological advances kind of falls in the same category as input prices usually, because we would think that if the company is able to use a faster machine than it used to, so it's a technological advance, well, it's usually going to result in costs falling, or those input prices falling. So if there's a technological advance, again, that tends to reduce the price of production, the cost of production, I should say. We have expected future prices being a factor, again. On the consumer side of things, we said that, well, if the price tomorrow goes up, people buy more of it today when it's relatively cheap. Suppliers will sort of be the opposite. If they think prices are going to be higher tomorrow, then they want to sell more when the price is higher tomorrow, and they might actually reduce their supply today. They might actually restrict their supply today, or even if today's price is the same. And again, the supply curve reflects not just one supplier of this product, but all of the willing and able suppliers. And so if there are more of them, then even if the price of the product stays the same, that's going to affect the quantity supplied too. And you get this general supply function where the quantity supplied is a function of these different variables. Just like before, you can have this general supply function written out as this big long equation with an intercept term h and these different variables with their coefficients out front. We'll call those slope parameters when we get into the later statistical chapter where we do regression analysis. But it's the same sort of thing. If the price of the product changes, then the effect on the quantity supplied will be registered through that variable k. Again, presuming that all of the other variables are being held constant. The sign works the same way as it did before. if these variables, these slope parameters, have a positive sign, then that means that the variables have a direct relationship with the quantity supplied. And we would expect that with the price of the product. So we would expect K to be positive in the supply function. If there's a negative sign, that indicates an inverse relationship. Just like before, we can show the relationship between these different variables and the quantity supplied and come up with some guesses about the signs of these slope parameters. So for the own price, we expect that there would be a direct relationship here. As the price of the product goes up, sellers would be willing to supply more of the product. That would mean that that K coefficient would be positive. When we had these other input prices, PI, then we would expect, these are all costs to the business. So if the wage goes up, that's one of the input prices, then that would increase the cost of production and reduce the profitability of supplying this product. So as the input price goes up, there's an inverse relationship with the quantity supplied, and we would expect that parameter value to be negative. Prices of related goods in production. Again, companies may have a particular production process where they might be able to produce two different types of products somewhat easily, and if the price of a related product that they could produce were to rise, then they would say, well, we should produce that other product instead, since it's a higher price, more profitable for us, and we're going to reduce the production of this current item we're talking about. So that would be an inverse relationship, make that coefficient negative. Or you could have, again, the opposite sort of thing, where it might be easy for a business to produce two different types of products at the same time. The book goes into some examples of crude oil, natural gas, nickel and copper, that sort of thing. And so again, if the price of one of those products were to rise, then it would entice the business to produce more of that product, and as a sort of a side effect, they would get more of the other product too. So there'd be a direct relationship there, and that coefficient would be positive. T was our technology, and again, to the extent that technology affects costs of production, when technology improves or when there are technological advancements, then that would cause the quantity supply to go up, and that coefficient to be positive. Again, it's probably kind of hard to quantify that to a certain extent. But if we just sort of realize that most technologies tend to reduce costs of production, then you can see the relationship. Price expectations. Again, we said that if suppliers expect future prices to be higher, then they may hold off a little bit today and wait to sell more of their items tomorrow when the price is higher. So they would reduce their quantity supplied today, making that relationship inverse and making that slope parameter negative. The number of firms in the industry would also be direct. If there are more firms, then even if the price stays the same, the quantity supplied would go up, making that coefficient positive as well. We can simplify things somewhat and say, well, what's the relationship between just the quantity supplied and the price, holding everything else constant? And we call it the direct supply function. It's fairly simplified. And we didn't discuss it here, at least in the slides I didn't. But you also get this law of supply describing the relationship between these two variables. Again, as the price goes up, we expect the quantity supplied to go up. As the price falls, we expect the quantity supplied to fall. But again, by virtue of how we draw these graphs with price on the vertical axis, quantity on the horizontal axis, then we may need to flip that direct supply function around and get P on the other side. So we get this inverse supply function where P is a function of the quantity supplied. Okay, to graph these things, it's a positive relationship, and every point on the supply curve, again, is going to sort of represent an extreme situation. The demand curves show the extremes for the buyers, either the largest amount they would be willing to buy at a particular price, or the highest price they were willing to pay to purchase a certain quantity of these items. Same sort of extremes for the suppliers, though, and it will reflect either the highest amount of a product that the companies are willing to sell at a particular price, or a minimum price that would be required for producers to receive in order to sell a particular quantity. So again, it's two extremes for these sellers to consider. And we can draw a supply curve, and of course it'll have this upward slope to it, representing the law of supply, the fact that as the price goes up, quantity supplied increases. The equation of this line would be the inverse supply function there, P equals 20 minus 0.05 QS. You can algebraically flip it around to get this direct supply equation also. Well, when we want to graph these things or figure out the relationship between these variables, then we see that, well, the supply curve itself allows me to see the result of a particular change. If the price of the product itself changes, then I can see how suppliers respond by looking at that one single supply curve. If the price changes, really all I do is move from one point on the supply curve to another one. But there were these other factors that mattered also: input prices, technology, expectations. So if those things change, and even if the price of the product stays the same, the amount that sellers are willing to sell is going to change too. So we call that not a change in the quantity supplied, but a change in the entire supply curve. The entire supply curve is going to shift. And again, this happens when one of those other variables changes. One way you might think of this is when I talked about the law of demand, the law of supply, I said that when the price changes, there's this change in the quantity, everything else equal. That statement by itself, the first part of it, when the price changes, the quantity changes, that you can sort of think of as, well, if that's what's happening, if it's just the price changing, then all I need to do is I stay on the same curve that I'm at. But if it's, when I said the second part of it, everything else equal, well, if everything else is not equal, like there's a change in consumers' income, or if there's a change in the input prices, then, well, everything else is not equal now. So that original curve that I had no longer applies, and I need to move it somewhere. So in this case, on the supply curve, if there's a change in the wage of workers at the company, then even if the price of the product stays the same, I'm not holding everything else constant anymore because the wage has changed. So I have to shift my supply curve around. If the wage goes up, then I would presume that, well, the company has to pay its workers more, so the product itself is less profitable, so there would be less supply, and I would end up shifting my supply curve to the left. If something happens where I'd expect there to be more supply, I would shift that supply curve to the right. So you'll also notice that the directions for those shifted in the same way. So if I thought there was more demand, I also shifted the demand curve to the right. Same way with the supply. If I think there's less demand, I shifted the demand curve to the left, just like with the supply curve. So here's some hypothetical supply curves again, based on pictures from the book. Here's our QS0, and if something occurs where there is an increase in supply, so if technology increases, cost of production decrease, then there'd be this shift outward to the right. It looks like it's shifting down, but if you look at it, each dot is actually moving to the right, so it's a rightward shift, a more supply. Well, let's say this is our original supply curve is S0, and there's an increase in worker wages after a strike or something like that. Well, that would tend to reduce supply, and the supply curve would shift to the left, to S2. Alright, well, we know how individual demanders behave, we know how individual suppliers behave, so let's put them all together into a particular market so that they can meet one another. We notice that when this happens, when buyers and sellers come together in a market, then predictable things tend to occur. You know, you could drive to gas stations around town and get prices that are on a particular day that are pretty similar. If you walk into any store that sells clothes, you can probably expect that jeans are going to be relatively similar in price, at least the same, brand, style, that sort of thing. And this suggests that there's something predictable going on. And this predictability of markets we refer to as market equilibrium. And it's just a situation where demand and supply curves intersect, where they come together. And since each of these curves showed the quantity of the product that was willing to be bought or sold at different prices, then there has to be agreement on the part of buyers and sellers with how much they're going to demand and supply at different prices. There were a lot of prices that the demanders were willing to accept. There were a lot of prices that the suppliers were willing to accept, and they might actually have considered the same price to be acceptable to both. So buyers might have said, yeah, $2 for this thing is fine. Sellers might have said, okay, $2 for this product is fine. But they're usually going to disagree on the quantity, on the amount that is bought and sold. But there's one place where both the price and the quantity are agreed upon, and that's at this equilibrium situation. A single price where the amount that both sides are willing to supply and demand is exactly equal. And it's kind of an amazing thing, because if you think about the preferences of both sides, they're completely opposite. The demanders like low prices, the suppliers like high prices, so they have completely opposite goals in engaging in this market, and yet we end up at this equilibrium most of the time. So we had our demand curve D0 from before, our supply curve S0 from before, and again you see these diametrically opposed preferences. Buyers like low prices, sellers like high prices, Well, let's think of other situations first. We don't have to be at equilibrium first. So if you think about an $80 price, and I can see visually that at the $80 price, the supply curve is further to the right than the demand curve is. Again, a seller might say, yeah, $80 is a fine price. Demanders might say, okay, yeah, $80 is okay with us. They're going to disagree on the quantity, though, because the sellers will say, at $80 we want to sell 1,200, and the buyers say at $80 we want to buy 600. So they may agree on the price, but they disagree on the amount. And if they can't agree on both terms, then no trade's going to happen. And we would end up, if the price we're currently charging $80, then there'd be too much being supplied. There'd be an excess supply, or sometimes they call it a surplus. And then you ask, well, how would the market respond to the surplus? Well, the sellers would say, well, gosh, there's all this product that we're not selling, and how can we entice more buyers to want to buy? Well, if we lower our price, then we'll move further to the right on the demand curve. We'll increase more customers to come. And again, the problem is that we don't have enough customers now as it is. We have all this product going unsold. So if we lower the price, we'll encourage more demand. The other thing that happens when the price falls is that you discourage some sales. And so you would move back along the supply curve. If both sides tried charging a $40 price, or if the sellers tried charging a $40 price, again, both sides might find that okay. $40 is okay. There you can find some demanders at $40, you can find some suppliers at $40, but they disagree on the amount again. Sellers would only be willing to sell 400 units. Buyers would only be willing to buy 1,000 units. So there's much more being demanded than supplied in this case. We call that excess demand or a shortage. What happens when there's a shortage? Well, sellers realize that they've sold out of their product extremely fast. There are still all these customers waiting around saying, hey, you said you were going to sell this product at $40 and I don't see it. So they realize there's a lot of demand there. They just sold out really quickly. And again, they sold out quickly because they didn't produce that much, because $40 was a relatively cheap price, not very profitable for them. So all this extra demand that's out there, they realize they can probably raise the price. As they do that, they're going to discourage some demand. So we'll move backwards on the D0 curve, back towards point A. But raising the price encourages more production. And when both of those things happen, when you discourage consumption and you encourage production, again, you fix the shortage problem. You can see what's happening. When we started at 80, the pressure was for the price to fall. And when we were at 40, the pressure was for the price to rise. So we're moving toward a single price. We're moving towards a situation where there is no surplus, where there is no shortage. And that only happens where the curves cross at the equilibrium point A. $60, 800 units, both sides sort of have that on their curve. And they'll come to agreement. There's no need to change the price. There's no need to raise it or lower it to get rid of a surplus or get rid of a shortage. Both sides find that beneficial. There's no products that go unsold, like in a surplus. And there's no customers going home empty-handed, like in a shortage. When markets are at equilibrium, it's kind of a nice, happy place. The prices that are being charged help to clear the market, so the exact amount that is being brought to the market for sale is bought up by all of the customers. And again, there's no customers going home empty-handed. There are no products sitting on the store shelves unbought. And so it's a nice, happy place, but of course, things don't always work out that smoothly, and you might have situations where the price is somewhat too high or too low, where there's a shortage or a surplus. And again, a shortage is where you have excess demand, when the quantity demanded exceeds the quantity supplied at the particular price. And again, this happens when the price is below the equilibrium price. You end up with a shortage in that case. Excess supply or a surplus is the opposite, when the amount supplied exceeds the quantity demanded, and this will happen when the price is above the equilibrium price. The nice thing about markets, if they're allowed to operate on their own without any sort of interference as to what the price can be, is the price tends to adjust to get rid of these things, to get rid of shortages and surpluses. And neither of them are beneficial to everyone involved. It doesn't benefit consumers to have a shortage. I mean, it may benefit some people who are able to get the price cheaply, but it certainly doesn't benefit the people who have to go home empty-handed, especially when they sort of get misled into thinking that, hey, I saw the ad, this thing was supposed to be on sale for $40, and you sold out really quickly. Well, that makes me upset. For the company also, they recognize that there are some people willing to buy, and if there's a shortage, they haven't sold to everybody. They ran out of their product too quickly. So it doesn't really benefit the company to have a shortage either. It doesn't benefit either side to have a surplus. Obviously, it doesn't benefit the company too much. Well, let's do it the other way. The consumers feel like this thing is too expensive, and so there's not enough demand at the current price. the sellers, again, you might think that they're happy with having the price be high, and they certainly would be if they could sell everything. If they could sell everything they produce, that'd be great for the company, but they're not able to. By definition, you have this surplus where there's not enough consumers there to buy everything that's produced. And so, it might be fantastic that you try to sell a hot dog for $50, and you might get one or two people being willing to buy it, but you're certainly going to have, at the end of the day, a bunch of hot dogs left over that you wasted time and effort to produce, but weren't able to sell. So a surplus doesn't help either side. A shortage doesn't help either side. When we allow the price to adjust on its own, it eliminates these shortages and surpluses. We see markets all over the place. Anytime you probably engage in markets several times a day where you buy and sell things. And one question you might ask is, well, why do people do this? It seems like an odd social convention. Why they decide to trade these little pieces of paper for these items that they want? Well, because people benefit from them. We wouldn't do these things if we didn't benefit from them. And we might try to measure the amount of happiness that people obtain from engaging in market exchanges. And it's a little odd maybe to think about how you can measure someone's happiness. It's kind of weird to think about, well, I was 13% happier today than I was yesterday. Kind of odd to do that, especially when you're talking about buying products. Well, when I bought that Coke, it made me 6.8% happier than the other day when I had a Coke. So it's a little odd, but we can measure this somewhat. We have these terms of consumer surplus and producer surplus. And the idea of consumer surplus kind of relates to the notion of, well, most people have an idea of how much they'd be willing to pay for something, or how valuable they find the product to be. When they actually get to the store, though, the price they pay usually is a lot less than that. And so they benefit from that exchange. The fact that I can buy a product for less than I'd be willing to pay for it generates some happiness for me. And of course, instead of calling that consumer happiness, we call it consumer surplus, because economists have to invent strange new words for things. So consumer surplus is this difference between the value that I place on a product, which again was reflected by how much I demanded it, the demand curve, and the market price that I actually pay. If someone's willing to buy a product, then that consumer surplus must be some positive value. If the market price was higher than your willingness to pay, well, you wouldn't buy it to begin with. A similar sort of concept on the producer side of things, where sellers have a particular minimum price they'd be willing to charge to sell a product, but a lot of times the price they end up charging, or that consumers end up paying, is higher than that. So if you've ever talked with anyone who worked at a restaurant, they probably tell you that to produce a can of or a glass of Coke is really, really cheap. I mean, the syrup and carbonated water and all that stuff, you could probably get a glass of Coke for a couple pennies. But of course, they charge you $1 or $2 depending on where you're at. So the seller may have been willing to sell you that Coke. The bare minimum they might be willing to sell it to you may be a couple cents, 5 cents, 10 cents. But you're willing to pay $1 for it, $2 for it. So that generates a lot of producer surplus for the seller. The market price is a lot higher than the minimum price that the producer would be willing to accept. And again, that minimum price producers are willing to accept was reflected in the supply curve. So when we think about how beneficial is it for people to engage in market exchange, when you have the consumers being made happy from exchange, you have the producers being made happy from an exchange, and that sort of represents all of the happiness. One thing that you sometimes hear is that, well, anytime there's an exchange between two people, if one side comes out ahead, the other side has to come out worse. And so, like if you have a store and there's a sale that occurs, well, the consumer ends up with a lot less money afterwards, and the producer has all this money from the customer, and so the consumer loses and the producer benefits. And you might think, well, I can't see how that's helpful for everybody. But obviously, the consumer wouldn't have been willing to part with their money to buy this product. They must have valued the product more than the money. And the producer was the opposite. They must have valued the money more than the product. So at the end of the day, after the trade is over, both sides are better off. There's a positive amount of consumer surplus and a positive amount of producer surplus. So the total amount of social surplus is the sum of those two. When you have your supply and demand curves and you've figured out where the equilibrium price is, then you can get a visual image, these triangles, of how much consumer surplus and producer surplus there is. So the price was $60 here, the demand curve is D0. Again, the demand curve told me the maximum amount people would be willing to pay for this product, but they only have to pay $60. So there were a few people willing to pay $120, some people willing to pay $100, some people willing to pay $80. but they didn't have to pay those prices. They only had to pay 60 because that was the equilibrium price. And so everyone who is willing to pay more than that, more than $60, benefits from this exchange. And you get this reddish triangle on the top that represents consumer surplus. Sellers, on the other hand, again, there were some sellers willing to sell for $30, some sellers willing to sell this product at $40, some willing to sell the product at $50, but they didn't have to. They got to sell the product for $60 because that's what the equilibrium price was. So all of those people, all of those sellers are happy about this exchange too, and you can measure that amount of producer surplus as the gray triangle there. Well, this is the most fun part and probably the most powerful part of using supply and demand analysis. It's one thing to look at the little X that these two lines make, to look at the demand curve and the supply curve and figure out where the equilibrium price is and the equilibrium quantity. That's kind of interesting. But what really makes supply and demand analysis powerful is to realize that, well, markets change. There are these factors that change. There may be more consumers that move into an area, or there may be sellers that move out, or the change in technology, change in resource prices, that sort of thing. So how did the market respond to that? Thinking about how these markets change, there's two aspects to it. A lot of times there's quite a bit of abstraction, and you're just drawing these two lines to represent a lot of different factors in this market. And so sometimes really all we can do is to say, well, if these curves are going to shift, if one of the curves shifts, then I can make a presumption or an assumption, a guess about what will happen to the price and what will happen to the quantity. And a lot of times I can't say much more than, well, I think the price is going to increase or I think the quantity is going to decrease. So that would be making a qualitative forecast. If things are very precise and you have a lot of data and you've constructed, you're very confident in what your demand curve looks like, same thing with your supply curve. If you have a lot of data and you know what your supply curve looks like, then you may be able to make what they call a quantitative forecast, where if you know not only what your supply and demand curve look like, but if you know what the changed curve would look like. Well, if the demand curve is going to shift out to the right, if you know how much it's going to shift and you know exactly where the new curve is going to be, then you might be able to say that, well, not only is the price going to change, but it's going to change by this percent, or it's going to change by this many dollars or something. Not only is the quantity going to change, but it's going to change by this many units. That requires a lot more sophistication. It's a lot harder to make those, a lot easier to make the qualitative forecasts. So we can think about if the supply curve stays where it is, but there's a shift in demand, we can ask ourselves what will happen. Well, if the demand curve increases because of some event, if the price of a complement were to fall, then that would cause the demand for the product to rise. The original equilibrium price was at point A, $60 and 800 units. And once the demand curve shifts, though, that point A, the point capital A, is not going to be the equilibrium anymore, because now with this new demand curve D1, at point A, I have excess demand. At $60, there's excess demand now. And you can see it by the gap between that capital A and that little a prime. There's this gap between the supply S0 and the demand D1. So there's excess demand at that situation. And what's going to tend to happen is that, well, like every time there was excess demand, the price is going to tend to rise. And I'm going to have this new equilibrium point of point B. So I can make a qualitative guess and say that if there's an increase in the demand where supply stays constant, then there's going to be an increase in the price and an increase in the quantity. And again, I may not have enough information to be able to say how much the price is going to go up or how much the quantity is going to go up, but I can make some guesses. And again, maybe if you do have a lot of good information and good data where your graphs look like this, you could easily enough figure out where that point B is located and say that it's $72 and 930 units or something like that. If demand drops to D2, then again, at the original equilibrium point A, that $60 price is too high now. There's an excess supply after this reduction in demand. And what's going to tend to happen is the price is going to fall down to point C. Equilibrium will be at point C now. And again, qualitatively, that's at a lower price and a lower quantity. On the other side, there may be supply shifts where the demand curve stays constant. So there's my D0, S0 equilibrium again, $60 price. If demand stays the same, but there's an increase in technology and improvement in technology, then even charging the same price at 60 results in a surplus now, because the technology improvement allowed companies to produce more and more profitably. So they increase their supply. Now there's a surplus at $60, and it's going to tend to push the price down. There's this equilibrium point B, so qualitatively a lower price. What's also nice, and I should have mentioned it in the previous slide, is that these events should cause predictable changes in prices and quantities. So if there's a technology improvement, even without knowing anything about supply and demand, I could probably guess that having better technology is going to lead to lower prices and higher quantities. Technology, again, it makes things cheaper to produce, and they should be able to produce more of them. So once I introduce the graph, then I can say, well, in class we always said that technology improvement causes the supply curve to shift to the right. Once you've done that and you've seen that point B is at a lower price and a higher quantity, you can say, well, that's consistent with the guess that I had before. So that's kind of nice. If there's a reduction in supply, if there's an increase in wages, then again at the point A, price, $60 price, well, now there's excess demand. If there's a reduction in supply, then there's not as much available as there used to be. Even if there's the same demand, now there's a shortage, excess demand. So the equilibrium would move from that capital letter A up to point C, qualitatively higher price, lower quantity. You might say, well, what happens in a situation where the demand curve and the supply curve shift at the same time? You have these simultaneous shifts. So what happens if there's an improvement in technology and there's a change in consumers' incomes, let's say? Well, it gets a little dicier and gets a little harder to make some accurate. You can show easily enough what happens in the graph, but being able to make predictions about prices and quantities can be a little more difficult. A lot of times you'll have the ability to say what happens with one of those variables but not the other. You can either say something definitive about what you expect to happen to price, but you'll be not quite sure what will happen to quantity, or you'll be able to say for sure what's going to happen to quantity but not quite sure what's going to happen to price. So in this case, if we have demand increasing and supply increasing, we're starting at point A though, but if both of those curves shift, maybe we're here at point B, where there's an increase in supply and an increase in the demand. So we move from point A to point B, which is a higher price and a higher quantity. But maybe the supply increase is much stronger than the first supply increase was. And so I'm out at S double prime. Well, I would move from point A to point C then. And again, I'm not quite sure. I know there's going to be an increase in the quantity because both point B and point C show increases in quantity. But point B shows a higher price and point C shows a lower price. So I know for certain that if there are increases in demand and supply, that the quantity is going to go up. I'm not quite sure what's going to happen to the price though. If there's a drop in demand and an increase in supply, it could be that I'm at point B, which is lower price, lower quantity. Or again, maybe that supply curve is farther out, where there's a lower price and a higher quantity. So here I know what's happening to the price, I don't know what's happening to the quantity. Incidentally, we're showing different changes in the supply curves. It would be the same situation if you had the supply curve shifting a certain amount and two different changes in the demand curve. So here we end up, again, where we know the price is going to drop, but we're not quite sure what happens. Same sort of thing with these other, there's going to be four possibilities here. Demand increasing, supply decreasing. I know the price will go up, I'm not quite sure what happens to the quantity. Demand decreasing, supply decreasing. I know the quantity is going to drop, not quite sure what's going to happen to the price. Well, that's how markets work when they are unintervened in, if there's no situation where the price is forced to be at a particular level. But unfortunately, a lot of times lobbyists may get involved and the government may step in and say, well, we don't like that current equilibrium price, we think that's too high or too low. And they'll step in with some kind of a law to control the price. There can be two variations of this. There can be a situation where the government says there's a maximum price that sellers are not able to charge above. A lot of times you'll hear about this if there's a tropical storm. The government will come in and say that the price of gasoline cannot rise above a particular price. Well, we call that a ceiling price ceiling law. And usually these are set because people consider the current equilibrium price to be too high. And so the law will come in and say, well, you're not allowed to charge above a particular price. So if that equilibrium price that would result is higher than what the ceiling price is, then you're going to have a shortage. And we'll see this in more detail in the next slide. It can also be price floors, which is a situation where the government says there's a minimum price that you can't sell below. And we might think of the minimum wage as an example of this. If you want to sell your labor, companies want to buy your labor, then they can't pay below whatever the minimum wage is. They can pay something above that, but they can't pay below it. Again, usually this happens if people perceive the current equilibrium price to be too low. And so we want to set a price floor that's above that too low equilibrium price. And when this happens, usually there's a surplus that occurs. So again, if we have a situation on panel A, maybe it's the market for gasoline after a storm, where everyone's wanting to buy gasoline to drive out of town, or if there's a hurricane company and they want gasoline to leave, and there's not as much supply. So the equilibrium price might be relatively high, but the law might come in and say, no, you have to charge $1 a gallon instead of $2 a gallon. You can tell I didn't think about this example very well. It's been a while since gas has been $2 a gallon. But in this case, again, if the law says you can't charge above the ceiling, you can't charge above $1, then you're going to sort of perpetually be stuck with this excess demand, with this shortage. And of course, what you see usually when the government comes in with these kinds of laws during storms and trying to control the price of gasoline, what usually happens is, sure, the price at the pump says $1, but what you also see at the gas station is there's tons of people. I mean, the market itself would result in an equilibrium price of $2. Everyone would get the gasoline they would want. Everyone willing to buy at $2 would get it. Companies willing to sell at $2 would be willing to sell everything. But if you force the price to be lower, then you're going to always have this shortage. You're going to always have this excess demand. And so you see long lines for gasoline and the stores closing and selling out of gas in a few hours. And I'm not quite sure how that helps people who want gas. I mean, yeah, the first people in line get their gas for $1 a gallon. That's great for them, but what about everybody else? On the opposite side, you have this price floor. And again, since I used minimum wage before, we can talk about that, even though a $2 wage is kind of ridiculous. But we'll say that maybe for certain types of labor, low-skilled labor, young workers, the equilibrium wage would be $2 an hour. But the law comes in and says, no, you're not allowed to pay anybody less than $3 an hour. For these kinds of workers, there's not much demand for workers of that skill level at a $3 wage, but there's certainly a lot of workers of that type who might be willing to work at $3. They might say to themselves, man, before this minimum wage law came in, I was only getting paid $2, or people I knew were only getting paid $2 an hour. Now this law says that we get to get paid $3. So a lot more people decide that they want to work, but a lot fewer companies have jobs for offer. And so you get this surplus of workers. You get the surplus of whatever product there's a price for. Excess supply. And again, it's kind of like, I don't know exactly how that helps people. It might help a few of the workers who are able to keep their jobs at $3 an hour. And certainly it doesn't help the people who are unemployed as a result of this surplus of labor.